At 9 a.m., one of your dependencies is compromised. 6 minutes later, your security team needs one answer. What is our actual blast radius? Searching package names isn't enough. You need to understand the relationships between packages, applications, versions, maintenance, and time. Okay, just like here. This is Hydra Sentinel, a graph native software supply chain intelligence platform built for Hydradb's Track O2A. Instead of treating dependencies as isolated documents, Sentinel models them as a graph. So when loaders 4.17 to 0 is compromised, we don't just tell you that the load hash is vulnerable. We trace the relationships. Here, Sentinel immediately identifies three affected applications, which is the checkout web, the payments, and our analytics worker. But this is where the graph becomes important. The vulnerable package isn't directly installed by the checkout web. It is four relationships away. A vector similarity search can retrieve information about the loaders, but the security question is a traversal question. What depends on it? And Sentinel doesn't stop at affected. Every finding is explainable. We show exactly which dependency path created the exposure, which version was resolved, when the compromise was published, and which fixed version should replace it. The system also prioritizes the blast radius when an explainable risk score, like we prioritize the blast radius with an explainable risk score, which we have here and as well over here too. But compromised dependencies don't exist in isolation. Sentinel also looks for related packages sharing maintenance, just like you can see. Sentinels looks for packages which are sharing the same maintenance. The nearby package names that could indicate typo squatting. These relationships become additional investigation signals, and this is where HydraDB becomes essential. Sentinel sends the investigation corpus into the HydraDBs uh, and uses graph enriched retrieval to recover related entities and multi-hoop context. The typical graph engine gives us deterministic dependency traversal. Okay, so HydraDB gives us second layer of graph aware context for the investigation. The graph isn't decoration, it changes the question we can ask. We are no longer asking what text looks similar to this vulnerability. We are asking what is connected to this compromised artifact, and what does the connection mean to my system. So the system is also designed around real injection. A dependency or a log file becomes structured evidence that can be analyzed and retrieved through the graph. Software supply chain attacks, just like software supply chain attacks move through relationships. So your security tooling should understand relationships too. Hydra Sentinel turns dependency data into an explainable attack graph. So when a package is compromised, you don't have to guess your blast radius. You can trace it, understand it, and act on it. Thank you.